Howdy. This video will focus on inconsistent and consistent linear systems, as well as solving some more systems of linear equations. First off, can a system of linear equations have more than one solution? By definition, a line is straight, so it doesn't curve and it doesn't bend. So once two straight lines cross, they keep on going indefinitely, and so they only cross once. They don't turn back around and cross again. That's a no-no, and that does not happen. Okay, so let's ask ourselves, why is it not possible for a system of linear equations to have exactly two solutions? Like I just said, by definition a line is straight, so once a straight line crosses another straight line, that's it, there's only one solution. Now ask ourselves, what is an inconsistent system of linear equations? An inconsistent system of linear equations is two linear equations that have no solution. Now think to yourself, what kind of lines never have a solution? What kind of lines never cross? That would be parallel lines. These two parallel lines are inconsistent and have no solution. So two equations would be, say, y equals 2x plus 1 and y equals 2x minus 2. The slope of these two equations is the same, so that means they are parallel and they never cross. What is a dependent system of linear equations? A dependent system of linear equations is consistent. So consistent. And this system has multiple solutions. But wait, didn't we just say that a system of linear equations can't have exactly two solutions? Well, check this out. Two lines that are equal to each other have more than one solution. Every point on this line is a solution to the system of equations. So let's say that would be y equals x plus 1 and 2y equals 2x plus 2. This is a very simple example, but these two lines are the same. This is just the factor of 2 of this equation. So, in other words, there are infinite solutions to a dependent system of linear equations. And last, but most important, is an independent system of linear equations. This system of linear equations is most common because, as what we most often see, two linear equations that have one solution. So an independent system of linear equations is consistent, and there is one solution only. Now we're going to solve for y and then solve the linear system of equations. So given 6x minus 4y equals negative 24 and negative 2x minus y equals 8 plus 3y, solve the linear system equations by the graph. So let's first solve for y on both equations and then figure out our slope and our y-intercept. So let's write this here. We're going to have 6x minus 4y equals negative 24. And first ask ourselves, are there any parentheses? Nope. Are there any fractions? No. So now let's focus on getting our y's on the left side and our x's on the right side. So we have an x on the left side that we need to move over, so let's subtract 6x from both sides. So then this cancels, and we're left with negative 4y equals negative 24 minus 6x. Now, we want y by itself, so we have negative 4 times y. We need to divide by negative 4 to get rid of the negative 4, so let's divide both sides by negative 4. This cancels, and we're left with y equals negative 24 divided by negative 4 is positive 6. Negative 6 divided by negative 4 is positive, so plus 3 over 2x. proper form, we need to switch these two around. So that will give us y equals 3 over 2x plus 6. Our slope of y equals 3/2 x plus 6 is m equals whatever is in front of our x, which is 3 over 2. Our slope b is whatever we're adding to the x, or subtracting from x, which is going to be positive 6. Now let's focus on our other equation, which is negative 2x minus y equals 8 plus 3y. Are there any parentheses? No. Fractions? No. So let's move over our 2x to the right side. So add 2x to both sides. And move our 3y to the other side. So minus 3y on both sides. The 2x cancels, the 3y cancels. We're left with negative 1 minus 3 is negative 4y equals 8 plus 2x. Now we want to get rid of this negative 4. So let's divide both sides by negative 4. So that cancels. So we're given y equals 8 divided by negative 4. That is negative 2. 2 divided by negative 4. That is negative 1/2 x. In proper form, this is y equals negative 1/2 x minus 2. Now our slope will be whatever's in front of x. So m will equal negative 1/2. And our y-intercept is whatever we're adding or subtracting to x, which is negative 2. So b equals negative 2. So let's go ahead and plot these two equations. Let's start with our first equation, which has a y-intercept of 6. So move up 6 from the origin. So 1, 2, 3, 4, 5, 6. And we're going to go up 3 and over 2 because of rise over run. Now let's go ahead and focus on our second equation. We have a y-intercept of negative 2. And our slope is negative 1 over 2. So we're going to go down 1 and right 2. Down 1, right 2. Down 1, right 2. And let's connect our dots. Okay, now solve the linear system of equations by graphing. We have an intersection right here, and that intersection is at the point negative 4, 0. So our solution to this linear system of equations is negative 4, 0. We now need to plug this back into our equation. So plugging the negative 4 into our equation and our 0 into our first equation, we're going to have 6 times negative 4 minus 4 times 0 equals negative 24 minus 0, and negative 24 minus 0 is negative 24. So that works. Plugging our negative 4 into x on our second equation and the 0 into our y on our second equation, we're given negative 2 times negative 4 minus 0 equals 8 plus 3 times 0. This equals 8 minus 0 and 8 plus 0. Therefore, 8 equals 8. So our points of negative 4, 0 is correct, and we have found our solution to our linear system of equations. Now, given our table, let's solve this system of linear equations for y, and then find the solution by using the table. So first, let's solve for y on the first equation. So we're given 4x plus 2y equals 8. First step, we're going to ask ourselves, are there any parentheses? No. Are there any fractions? No. Now we just want to focus on getting our y's on the left side and our x's on the right side. So we have a 4x on the left side, so let's move it over to the right side by subtracting 4x, because we have a positive 4x. To get rid of it, we need to subtract it. So subtract 4x from both sides. So we're left with 2y equals negative 4x plus 8. Now we want to get y by itself, so we need to divide by 2 because we have 2 times y. To get rid of the 2, we need to divide by 2. So divide by 2 on both sides. So we're left with y equals negative 4 divided by 2 is negative 2x. 8 divided by 2 is 4, so plus 4. Solve for y for the second equation. So negative 2x minus 6y equals 36 plus 4x. There are no parentheses, there are no fractions. So let's move our 2x to the other side so we can get our y's on the left and our x's on the right. So plus 2x on both sides. That cancels. We're left with negative 6y equals 36 plus 6x. Let's divide by negative 6 so that we can cancel that out and get y by itself. We're left with y equals 36 divided by negative 6 is negative 6. Positive 6 divided by negative 6 is negative 1, so minus x. Proper terms, we'll have y equals negative 6 minus 6. Now, using our table, we're given our x's. Let's input these x's into our equation. So let's use negative 10 first. So let's put negative 2 in for let's put negative 10 in for our x plus 4. That's going to equal 20 because negative 2 times negative 10 is 20 plus 4 equals 24. Let's do negative 5. So negative 2 times negative 5 plus 4. Negative 2 times negative 5 is 10 plus 4, that's 14. And then now 0, so negative 2 times 0 plus 4, that equals 0 plus 4 equals 4. So what's our pattern here? We're going down by 10, 24, 14, and 4. So 4 minus 10 is negative 6. Negative 6 minus 10 is negative 16. Now let's focus on our second equation. Let's plug in negative 10. So negative 10 minus 6 is 10 minus 6 equals 4. Let's plug in negative 5. So negative 5 minus 6 equals 5 minus 6 equals negative 1. So 4, negative 1. Now let's plug in 0. So negative 0 minus 6 equals 0 minus 6 equals negative 6. What's our pattern here? We are going down by 5. Correct? So what is negative 6 minus 5? That's negative 11. Negative 11 minus 5, that's negative 16. Now let's look at our table and see which one of these has the same x and y. And lo and behold, it's our last one. So the solution to this linear system of equations is 10, negative 16. And that's all, folks. So please remember to take your notes, and I will see y'all in class.